Hey, welcome to The Explainer. So today we're going to dive into something you see literally every day, but probably don't think twice about. How in the world do machines actually make sense of our words? It's the tech behind everything from your email spam filter to online review sites, and believe it or not, it all kicks off with an idea that's almost shockingly simple.
You know that feeling? You'll leave a product review and boom, the app instantly knows if you loved it or hated it. Or you see comments on social media getting flagged automatically. How does it do that? It feels like some kind of magic, right? But the secret? It's actually super simple, and it all boils down to just counting.
Okay, so let's get one thing straight. A computer can't feel happiness from a good review or sadness from a bad one. It has zero understanding of emotion. But what it can do, and this is the key, is learn to spot the patterns in the words we use when we're feeling happy or sad.
Yeah, forget all the super complex sci-fi AI stuff for a second. At the very, very bottom of it all, teaching a machine to understand our language starts with something a kindergartner can do: teaching it to count words. This one idea, it's literally the foundation for so much of what comes next.
All right, so let's get into the main tool for the job. It's a really straightforward concept, but it is the engine that powers a huge chunk of what we call natural language processing, or NLP. That's just the fancy term for the field of AI that's all about how computers and human language can work together.
And here it is. It's called a frequency dictionary. Look, all this is a master list. Seriously, just picture grabbing a book, writing down every single unique word you find, and just putting a little check mark next to it every time you see it. That's it. This simple act turns messy human language into clean, organized numbers that a machine can finally understand.
I mean, can you imagine doing this by hand? People actually used to. But now, of course, software just blitzes through it automatically. And that's what makes it so powerful. You can do this for massive amounts of text, like every single tweet from a whole day. It's incredibly fast, and it just scales up perfectly.
You know, frequency dictionary sounds a little dry, right? So let's think of it a different way. Let's call it a word scorecard, because that's really what we're doing. We're about to see how we can keep score for every word, and those scores are exactly what give the machine its power.
And this is absolutely crucial. On our scorecard, these counts become what data scientists call features. The best way to think about it is like looking at a basketball player's stats. Points, rebounds, assists. Those numbers are the features that tell you how good the player is. We're doing the same thing, but for words. And then we feed those stats to a machine learning model so it can find the patterns.
All right, so counting words is cool and all, but that's not where the real magic happens. The real secret sauce, the big aha moment, is when we get a little smarter about how we count. This is where things get really clever.
So instead of just one big list, what if we split it? What if we made two columns on our scorecard? One column for counting how many times a word shows up in positive reviews, and a separate column for how many times it shows up in negative ones. This simple split changes everything.
Okay, let's make this super concrete. Imagine we have this tiny, tiny data set of just 4 tweets. We've read them and decided 2 are positive and 2 are negative. From those 4 tweets, we'll make our vocabulary, which is just a list of every single unique word that was used.
And here we go. This is our scorecard. You've got the words on the left and our 2 empty columns, positive and negative. Our mission, should we choose to accept it, is to fill in these blanks based on those 4 tweets we collected.
Okay, let's see how this works in practice. We'll start with an easy one, the word happy. And remember, we are only looking at the 2 tweets we've already labeled as positive. We're just going to count how many times happy appears in those 2 tweets.
Boom! The answer is 2. In our little example, the word happy showed up twice in the good tweets. Simple as that.
So we pop that right into our scorecard. Next to happy, under the positive column, we write a 2. And since it didn't show up in the negative tweets at all, it gets a 0 in that column. And just like that, we've translated the word happy into numbers a computer can actually get, 2 and 0. All right, let's do one more, just to really lock it in. This time, we'll take a neutral word, am. But this time, we're only going to look inside the 2 negative tweets. How many times does am show up there?
And in our little data set, the word am shows up 3 times in those negative tweets. So there's our next piece of data.
So imagine we do that for every single word on our list. What we end up with is this, a completed table. What started as a simple scorecard is now something a data scientist would call a feature matrix. And this is pure gold for a machine learning algorithm. It's pure, structured numerical data that an algorithm can finally learn from. Okay, so that's the how. But what about the why?
Why does any of this simple counting stuff actually matter so much in the world of AI and technology?
This right here, this is the whole point. Human language is, complicated and messy. Computers, they only get numbers. This table is the bridge that connects those two worlds. We've successfully translated something abstract, like human expression, into a language that a machine can finally process and find patterns in.
And once you have that bridge, the possibilities are, well, they're everywhere. This very basic technique is the engine behind analyzing thousands of product reviews in a second, monitoring a brand's reputation on social media, automatically sorting customer emails. It can even be used for things like classifying legal documents or even helping to identify an author's unique writing style. It really is a fundamental piece of the puzzle.
So think about what we just saw. A machine can get a sense of human emotion just by counting words, without any real understanding at all. Which leads to a pretty wild final thought. If computers can learn this much just by counting, what else are they learning about the way we talk and the way we think?